All right, last podcast, almost done.
Wow, we've almost made it through the gas laws. This is exciting.
One last one. Molar volume. I got to tell you, I'm a little nervous about that word mole.
Yeah, I love moles, actually, personally.
It means we have to do some stoichiometry.
Yeah, I love that, too.
There's a little bit of moles. Okay, molar volume. This is actually going to make our math a little bit easier. Yay, stoichiometry!
Yay, stoichiometry! Woo!
Molar volume is pretty simple. It deals with STP, and STP stands for standard temperature and pressure.
Yeah,
Do you know
standard
what-
temperature, 0 degrees Celsius.
0
or,
degrees Celsius.
Or 273 Kelvin.
Good job. You must have learned that from your first podcast.
I did.
You did.
I was listening, actually.
And
I was
the
taking
standard
notes.
pressure? No pressure.
1 atmosphere.
Lots of pressure, actually. 1 atmosphere of
Yeah,
pressure.
That's right.
1 atmosphere of pressure. And if you have those conditions, standard temperature and pressure, the volume, you don't really need to calculate it, because the volume of 1 mole of any gas, it doesn't matter what it is 22.4 liters.
Yeah.
Oh, that makes it so easy. That almost looks like a conversion factor. 1 mole equals 22.4 liters.
Ooh, that means we're going to have to do dimensional analysis.
Let's try some of that
Yes.
dimensional analysis. So let's try some of that stoichiometry there. Here's our conversion factor. We said that 1 mole of anything is equal to
That great number, 22.4 liters.
22.4 liters, just like the beach ball says. What volume would 23.4 grams of nitrogen occupy?
Grams?
Grams isn't related to that
Grams.
conversion I just had. What the heck? Well, grams, it's not in there directly, but if I have grams of nitrogen, N2 diatomic.
Yeah, don't forget diatomic.
Aren't you proud I remembered that?
Yeah, I am very proud.
Um,
of you.
I can relate grams to moles.
Right,
If
molar
you look on the
mass.
periodic table with molar mass, 28.02 grams of nitrogen is the same as 1 mole of nitrogen. So that's good, but that doesn't give me a volume yet.
Hey, we have a relationship between moles and liters now, so that
We
gets us
do,
volume.
don't we? Because we're talking about gases, and this is at STP. We didn't mention that in the problem, but let's pretend that it's at STP. 1 mole of nitrogen at STP is 22.4 liters of nitrogen. Grams are gone, moles are gone, and we're left with our volume. Pretty good. What's the answer?
18.7 liters of nitrogen gas.
18.7 liters of N2. All right, so molar volume, that made that a lot easier. That was easier than doing the ideal gas law. If it's at STP, you just do the conversion.
Yeah, a lot easier.
All right, let's try another one. Okay, this one I've got.
We actually have an equation.
I've
here.
got liters of
Chemical
hydrogen.
equation.
This really looks like stoichiometry. I have liters of nitrogen, and I'm trying to convert to liters of hydrogen.
Oh yeah, definitely stoichiometry. One
All right,
thing to another.
let's try. I've got 12.8.
So if I recall correctly, we're going to have to convert liters to moles, and then moles to moles.
Yeah, because these
And then
coefficients
moles to liters.
these coefficients represent moles.
Yeah.
So we're going to use these coefficients. Molar volume says 22.4 liters for every mole, and that's nitrogen. So that's good, but I don't want nitrogen. How do I get to the hydrogen?
So we got to do the mole to mole conversion. It looks like it's a 3 to 2 mole ratio
Right,
of
I've got-
hydrogen to nitrogen.
I've got nitrogen here, so I want my 2 moles of nitrogen on the bottom. That comes from that right there. Did I circle it enough?
Yeah, I think that made it
Okay.
clear. I think we got it.
And then 3 moles of hydrogen
Wait, where'd that one come from, though?
right there.
Oh, there we go.
I'm glad
There we
you
go.
asked. 3 moles of hydrogen. Now I've got moles of hydrogen. I want volume, so can I just use my molar volume again?
Yeah, I think we can. 22.4 liters is 1 mole.
22.4 liters is 1 mole of
Is this at
hydrogen.
STP? Maybe we can't.
It is at STP.
Oh.
This
We're
will
just
be
gonna-
written in the problems.
Yeah, or we'll just assume they're all at STP.
Yeah.
Because we can't do these otherwise.
Yeah. And I get 19.2 liters of
Hydrogen gas, H2.
Hold on a second there. I noticed that this conversion and this one cancel each other out.
Yeah, they're exactly the same. You're right.
So why did I write it twice? That's kind of pointless.
Huh. Does that mean we can just get rid of those steps in the stoichiometry?
I think I can.
Yeah.
Only because
yeah.
I'm talking about gases. Because every gas has the same volume. You can't do that with moles or
That's
or
why
with
that
grams.
22.4 liter number is so awesome.
So let me try that again. 12.8 liters of nitrogen. If I just treat the coefficients as volumes, could I say that there's 2 liters of nitrogen for every 3 liters of hydrogen?
It looks like we can do that.
That's the ratio from the balanced equation.
Let's just calculate it to make sure, because I'm not positive about that.
And it's still 19.2.
Yes, that simplifies our life so much.
So if you're going from liters to liters, the coefficients come in handy, and molar volume kind of takes a step out of it. You can just use the coefficients.
So our coefficients can represent moles or liters now.
Or liters. That's
Excellent.
very good.
22.4 liters,
yay!